In the last video, we began our exploration of what a consumption function is. And we saw it's a fairly straightforward idea. It's a function that describes how aggregate income can drive aggregate consumption. And we started with a fairly simple model of this, a fairly simple consumption function. It was a linear one. You had some base level of consumption regardless of aggregate income. And then you had some level of consumption that was essentially induced by having some disposable income. And when we plotted this linear model, we got a line. We got a line right over here. And I pointed out in the last video, this does not have to be the only way that a consumption function can be described. You might use some fancier mathematical tools. Maybe you can construct a consumption function. You have an argument. You'd argue that the marginal propensity to consume is higher at lower levels of disposable income, and then it kind of tapers out as disposable income, as aggregate disposable income goes up. And so you might think that maybe you should have a fancier consumption function that when you graph it would look like this, and then you would have to use things fancier than just what we used right over here. What I want to do in this video is focus more on a linear model. And the reason why I'm going to focus on a linear model is because, one, it's simpler, it'll be easier to manipulate, and it's also the model that tends to be used right when people are starting to digest things like consumption functions and building on them to learn about things like, and we'll do this in a few videos, the Keynesian cross. But what I'm going to do is I'm going to do two things. I'm going to generalize this linear consumption function, and I'm going to make it a function not just of disposable income, but not just of aggregate disposable income, which is what we did in the last video, but as a function of income, of aggregate income. And then we will plot that generalized one based on the variables. But it's really going to be the same thing. We're just not going to use these numbers. We're going to use variables in their place. So let's give ourselves a linear consumption function. So we could say that aggregate consumption, where we're going to have some base level of consumption no matter what. Even if people have no aggregate income, they need to survive, they need food on the table, and maybe they'll have to dig in savings somehow to do it. So some base level of consumption, I'll call that lowercase c sub 0, or lowercase c with a subscript of 0 right over there. That's the base level of aggregate consumption, or it's sometimes referred to as autonomous consumption. This is autonomous consumption, because people will do it on their own, or in aggregate they will do it on their own, even if they have no aggregate income. And then we will have the part that is directly due to having some aggregate income. And we call that the induced consumption, because you could view it as being induced by having some aggregate income. So above and beyond what the base level of consumption, people are going to consume some fraction of their disposable income. So we'll say disposable income. And they're not going to consume all of their disposable income. They might save some of it. So they're going to consume the fraction that's essentially their marginal propensity to consume. So this right over here, I'll do that in this orange color. Marginal propensity to consume. So that is marginal propensity to consume. And hopefully this makes intuitive sense. This says, look, if this was 100, people are going to consume 100 no matter what, 100 billion, whatever your unit of currency is. Now, if their marginal propensity to consume is, let's say it is a third, and you have now above and beyond this, people have disposable income of, let's say, 900. This is saying that they want to consume a third of that disposable income they're getting. That is, if you give them 900 of extra disposable income, their propensity to consume that incremental income, they're going to consume a third of it. And so this would be a third. So it would be 900. So let me give an example. So if you had a situation, so you could have a situation where C naught is equal to, what did I say? Did I say it was like 100? And if you have disposable income is equal to 900, and C1 is equal to 1/3, or we could say 0.3333 repeating forever, C1 is a third, then this makes sense. On their own, people would consume this much, but now they have this disposable income. Their marginal propensity to consume, if you give them 900 extra of income, they're going to consume a third of that. So then you're going to have, your consumption is going to be equal to, for this case right over here, your consumption is going to be 100 times, or plus 1/3 times 900. And so your consumption in this situation, your induced consumption, 1/3 times 900, would be 300, and maybe it's in billions of dollars, $300 billion. And then your autonomous consumption would be 100, and they would add up to 400. So once again, this is autonomous, and this is induced. Autonomous, this right over here is induced. Induced consumption. Now, I did write it in general terms. I'm using variables here instead of or constants really, instead of using the numbers that we saw in the last example. But I also said that I would express aggregate consumption as a function not just of disposable income, but of aggregate income. Not just of aggregate disposable income, but aggregate income. And the relationship is fairly simple between disposable income and overall income. We saw over here. In aggregate, you have income, but the government in most modern economies takes some fraction of that out for taxes, and what's left over is disposable income. And so, and just a reminder, income in aggregate income is the same thing as aggregate expenditures, which is the same thing as aggregate output. This right over here is GDP. So this right over here is, let me do this in a color. I've used almost all my colors. This is equal to GDP. So disposable income is essentially GDP, or you could say aggregate income minus taxes. I want to do the taxes in a different color. Minus taxes. So we can express disposable income as aggregate income. This right over here is the same thing as aggregate income minus taxes. So we can rewrite our whole thing over again. Aggregate consumption is equal to autonomous consumption plus the marginal propensity to consume times aggregate income, which is the same thing as GDP, times aggregate income minus taxes. And so we fully generalized our consumption function, and now we've written it as a function of aggregate income, not just aggregate disposable income. And to make you comfortable that this is still a line, if we were to plot it as a function of aggregate income instead of disposable income, let me manipulate this thing a little bit. So we could distribute C1, which is our marginal propensity to consume, and we get aggregate consumption is equal to autonomous consumption, and then we're going to distribute this, plus C, so we're going to multiply it times both of these terms, plus our marginal propensity to consume times aggregate income, and then minus our marginal propensity to consume times our taxes. And since we want it as a function of aggregate income, everything else here is really a constant. We're assuming that those aren't going to change. Those are constant variables. And so what we could do is we can rewrite this in a form that you're probably familiar with. Back in algebra class, you probably remember. You can write it in the form y is equal to mx plus b, where x is the independent variable, y is the dependent variable. If you were to plot this, on the horizontal axis is your x-axis. Your x-axis, vertical axis is your y-axis, that this right over here would have a y-intercept, or your vertical axis intercept of b right over there, and then it would be a line with slope m. So if you were to take your rise divided by your run, or how much you move up when you move to the right a certain amount, that gives you your m. Slope is equal to m. So the same analogy is here. We can rewrite this in that form where our dependent variable is no longer y. Our dependent variable is aggregate consumption, and our independent variable is not x. It is aggregate income. So let's write it in that form. So we can write it as dependent variable c, which we'll plot on the vertical axis, is equal to, it's going to be equal to the marginal propensity to consume times aggregate income, let's see, I was doing that purple color, times aggregate income, plus autonomous consumption, minus marginal propensity to consume times taxes. So minus marginal propensity to consume times taxes. Now it looks all complicated, but you just have to realize that this part right over here, this is all constant. And it is analogous to the b. It's analogous to the b if you were to write things in kind of traditional slope-intercept form right over here. So when we plot the line, if you have no aggregate income, this is what your consumption is going to be. So let me draw that. So once again, our dependent variable, I should say, is aggregate consumption. And our independent variable in this is no longer disposable income like we did in the last video. It is now aggregate income. It is now aggregate income. It is aggregate income. So if there's no aggregate income, this is the independent variable right over here. If there's no aggregate income, then your consumption is just going to be this value right over here. So your consumption is just going to be that value right over there, which is C0 minus C1 times T. And then as you have larger values of aggregate income, C1, that fraction of it, is what's going to contribute to the induced consumption. And so what you essentially have is this is the slope of our line. This right over here is our slope. Just to kind of draw the analogy, if you were to say, y is equal to mx plus b, or actually maybe I'll write it like this. If you were to write C is equal to m, and I don't want to confuse you if this m and b seem like completely foreign. This is where it comes from, kind of a traditional algebra grounding in slope and y-intercept. So if I were to say C is equal to my plus b, this is the slope. This is our vertical or our dependent variable intercept right over here. That's where we intercept the dependent variable axis, and this is our slope. It's our marginal propensity to consume. So our line will look something like this, where the slope is equal to the marginal propensity to consume, which is equal to C1. If people all of a sudden are more likely to spend a larger fraction of their income, then the marginal propensity to consume would be higher, and our slope would be higher, and we would have a line that looks like that. And we always assume that the marginal propensity to consume will be less than 1, so we'll never have a slope of 1, but we'll also never have a negative slope because we assume that this is positive. And if people are more likely to save than consume when they have extra income, then this line might look something like that, might have a lower slope.